So here we have our first two-column proof, and it's partially completed. So how does it work? It works by you're given a given, right, which is an equation, and then we have a prove, which is the equation that we need to end with. Right. So how do we do this? Well, we have a two-column proof. You see here we have two columns, statements on the left side, reasons on the right side. And we always start our first statement with the given. So the given statement is always the first statement, right? 6x plus 2 times the difference of x and 1 is equal to 30. And so the reason for the first statement is always given. So we're going to write given there. And then the next step we're going to take is, well, it's PEMDAS, right? So it's parentheses. Let me go ahead and write this. It's PEMDAS. It's parentheses, exponents, multiplication, division, addition, and subtraction. And so looking at this, we don't have any parentheses that we can simplify, right? Exponents, we have no exponents. Multiplication, there is a multiplication right here, the distribution of 2. Right? And so that's what we're doing here. We're distributing out the 2, and we get 2x minus 2. And so which of the algebraic properties allows us to do that? Right? And so it's not addition. We're not adding the same number to both sides of the equal sign. Not subtraction. We're not subtracting both the same number from both sides of the equal sign. Right? And if we go ahead and look our way down, you'll see it's the distributive property. So that's what I'm going to write here. I'm going to write distributive prop. Okay. And you can go ahead and write it all out, or we can go and shorten up, right? So we get DISTR period prop. Okay. And now what's the next step that we're going to take? Well, we are going to combine our like terms. So this 6x plus 2x, we're going to replace it with 8x. Right? And so what allows us to do that? Well, it's none of these, right? Addition, subtraction, multiplication, or division. It's not reflexive, not symmetric, transitive, not really, right? And then we have substitution. That's what we're doing here. We're substituting. We're taking 6x plus 2x, and we are replacing that expression with what that is equal to. We are replacing this with 8x. Right? Those two are equal to each other, so we're replacing it with 8x. This is substitution. So substitution prop. And we could shorten that up as well. Next, what are we going to do? We're going to add 2 to both sides of the equal sign, right? So that we can get to the statement D. And so what allows us to add to both sides of an equal sign? Well, we have addition property. So here is addition. I'm just going to shorten it up and say add prop. And then lastly, we are taking 8x equals 32, and we are dividing both sides by 8. So we get x divided by 4. And so what lets us divide both sides of the equation by the same number? That's the division property. So I'm going to say division property, like so. Okay. So let's go ahead and come over to here, and we can complete this exercise. What are we given? We are given the equation for Celsius given Fahrenheit. Right? You plug in Fahrenheit here, and that expression will give you the corresponding Celsius degrees. And we need to prove that Fahrenheit is equal to that expression there. Right? So what are we going to do? We're going to start with our statement. And so we number our statements. Over here they're letters, right? But let's go ahead and use numbers. So statement number 1 is always the given, right? So we're going to say C is equal to 5/9 times the difference of F and 32. And the reason for the first statement, we want to say 1, right? So these should be the same number. The reason for the first statement is always given, always. All right, so what's the first thing that we want to do here? Well, we want to get rid of this 5/9, right, this fraction. And you could distribute, but that would be a little messy. So why don't we get rid of that fraction? And we all know that we can get rid of that fraction by multiplying both sides of the equal sign by its reciprocal. So I'm going to say 9/5 times C is equal to 9/5 times 5/9. So what are we doing here? We're multiplying both sides of the equal sign by the reciprocal 9 over 5. So what's the reason for this? It's going to be multiplication property. And I'm going to shorten that up to multiprop. And then what are we going to do? Well, we'll go ahead and replace this expression here with what it's equal to. And that expression is equal to 9 over 5c. And I'm going to replace this expression with what it's equal to, right? This whole thing, actually. And we know that if we take a fraction and multiply by its reciprocal, we get 1. And 1 times a expression is just that expression. So we can rewrite this as Fahrenheit minus 32, like so. Right? And now what do we want to do? Well, we want to get rid of the, actually we want to move this 30. We want to solve for f, right? That's our proof. So we want to move the 32 to the other side. And so how can we do that? Well, we can add 32 to both sides, and we get 9 over 5c plus 32 is equal to f. Okay, and what lets us do that? Oh, I'm sorry, we didn't do the reason for number 3, right? What allows us to go from step 2 to step 3 is substitution. So I'm going to do subprop. And if you shorten up substitution, go ahead and write subprop. Okay, sub. Because when we write down subtraction, we're going to use subtract. So we're going to do, to shorten up subtraction, we're going to do subtract like that. Right? And that's to differentiate from substitution, which we're going to say sub. All right. So now to get from here to here, what did we do? We added 32 to both sides of the equal sign. So what lets us do that? It is addition property. So I'm going to do add prop. And then lastly, this is not the expression that we're trying to prove. We're trying to prove this expression. And you might be saying to yourself, well, that's the same thing. Yeah, I mean, it is the same thing, but we need to take one last step. We need the variable f to be on the left side of the equal sign, right? So that's what we're going to do. We're going to say 5 Fahrenheit is equal to 9 over 5c plus 32. Finally, we end with our prove statement. And our reason for that, right? What's our reason? What lets us flip the equation? Well, it's not reflexive property. Remember, we're ignoring that. Right? A reflexive property says same number equals same number, and that might be confusing to you, but I'll explain how we use it in the upcoming chapter. It is symmetric property, right? What a symmetric property lets us do, it lets us take an equation and flip it around. And that's what we're doing here. We're taking this equation and we're flipping it around. So then we're going to say reflexive property. Like so.